Welcome to Magnus Academy. I am made up of chemical compounds. That means we are atoms, or made up of atoms. Now, what does this mean? Well, all living things are made up of chemical compounds. Now, humans are chemical compounds, right? And even pigs or any other thing are made of chemical compounds. Chemical compounds are made of atoms and elements. We'll discuss elements in a different video, but today we are going to discuss the fundamental properties and structure of atoms. We are made up of atoms. We are not actual atoms because an atom is a very small little thing. We are not actually atoms itself, but we are made up of atoms. You cannot cut an atom, just to let you know. You may not take your chainsaw and cut into our poor little atom right here. No. Even if you do that, it won't work because our atom is going to stay a whole. 100 million atoms make up about 1 centimeter if you put them side to side in a row. If these are atoms, makes 1 centimeter. That's about, so let's say, kind of like the width of your hair is like thousands of atoms. Basically, get the idea? So here I have a picture of what an atom looks like if you look at it close. So before I was drawing circles, right? So this is like a more bigger view of that. Here we have the subatomic particles. So we call each part, all these circles, we call them subatomic particles. Subatomic particles. Our subatomic particles are, here we have an electron. Here we have a proton. This is a neutron. So proton, neutron, and electron are subatomic particles. Let's learn some properties of these. So protons are, let me write it in a different color, positively charged. Neutrons have no charge, and electrons are negatively charged. Protons and neutrons have about the same mass. So if you put them on a scale, they will equal about the same amount of mass. I don't know what I drew on the bottom there. About the same mass. Strong forces bind the protons here and the neutrons there together to form what we call the atomic nucleus. The atomic nucleus. Protons are positive and neutrons are neutral. So that means the atomic nucleus is going to be positive because having positive and neutral means it's going to be positive, right? So this is going to be positive. So the nucleus of an atom is always positive. This is always negative. Negative, negative. Always negative. Electrons form a cloud. So this cloud, this blue thing is the cloud I'm talking about. So we call this an electron cloud that has a negative charge. Negatively charged. There is an attraction between the positive and the negative charges of the proton and electron, and this keeps it near to the nucleus. There are two models of an atom. So these are two different models of helium, which is an element. And I'll talk about what elements are next week. So in our model 1, we have this as our nucleus, atomic nucleus. This is our electron cloud, which is negatively charged. And this is a more accurate version of what an atom looks like. Here we have model 2, which has this as an electron. And this is our atomic nucleus. This is also our atomic nucleus. I just didn't write that in here. Atomic nucleus. And they both have 2 electrons. So in here, they're shown as spheres, the electrons that are around the nucleus. And they are 2. So helium, yeah, they are 2. The reason why this is a more accurate thing is because they are not actually electrons around the, let's say this is the nucleus, that go around in like a direction like that. Like there's no fixed direction which they go. They can actually go in any direction. They do go in any direction. So if this is our nucleus, just pretend this has all the protons and neutrons. An electron will go like this. It can go this way. It can go this way, this way, this way, and basically every possible way. We don't want to keep seeing that. That's why we think of this as a better way, because this makes it seem like it goes in a circle, but it does not. It's actually all over the place. Let's talk about the mass of the subatomic particles and also atoms. The protons and neutrons, and neutrons are each 1.7 times 10 to the power of negative 24 grams, which are hard to use for small particles. So we use something called a Dalton. This is very important. It's called a Dalton because it's easier to use, because if we use grams, it's basically saying we have like a very, 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 very small number, and that gets confusing. So we prefer to use Daltons. Now in Daltons, 1 proton is equal to 1 Dalton. 1 electron is equal to 1/1840 of a Dalton. And then 1 neutron is equal to 1 Dalton. Usually when we find the mass of an atom, we usually take out our electron here due to the fact that it has a very small mass that doesn't make a big difference when we're computing the mass of a proton and a neutron. Well, the atom, we're computing the mass of the atom. You might come across many names like like atomic mass unit, AMU, and Dalton. They are all the same thing. They're just multiple names for the same thing. So now you know what Dalton is, you know what AMU and an atomic mass unit, which is basically AMU abbreviated, are. If we do practice and try to figure out, if I had 7 neutrons and 7 protons and 7 electrons. What is my mass? I just have to do 7 plus 7 is equal to 14. Because this gives such like little addition to it, it'll probably give like 0.9 or something like that. I'm not sure, I just made up this number. But it's probably not going to be a big difference to it. Like 0.0000 something like that.